Welcome to the sixth module titled Smart Contracts. Smart contracts were first introduced by Nick Szabo in 1969 as a set of premises in a digital form that includes protocols within each of the parties perform on these premises. What is a protocol, you may ask? In computer science, a protocol can be defined as a set of rules of procedures for transmitting data between electronic devices such as computers. In order for computers to exchange information, there must be a pre-existing arrangement as to how the information will be structured and how each side will send and receive it. A smart contract is a computer program or a transaction protocol that is intended to automatically execute, control, or document events and actions according to the terms of the contract or an agreement. The objective of smart contracts are the reduction of the need for trusted intermediaries or arbitration costs and fraud losses, as well as the reduction of malicious or accidental exceptions. Smart contracts are commonly associated with cryptocurrencies, as the smart contracts introduced by Ethereum are generally considered a fundamental building block for decentralized finance and NFT applications. So vending machines are mentioned as the oldest piece of technology equivalent to smart contract implementation. The original Ethereum white paper by Vitalik from 2014 describes the Bitcoin protocol as a weak version of the smart contract concept as originally defined by Nick Szabo, and proposed a strong version based on the Solidity language, which is still incomplete. Since Bitcoin, various cryptocurrencies have supported programming languages which allow for more advanced smart contracts between untrusted parties. In regards to smart contract technical features, I would say that they can be written in many programming languages. The most supported are Solidity and Rust. In addition, developers have created frameworks for executing smart contracts written in legacy programming languages such as Java, JavaScript, C++. Smart contracts can be executed in the proof of work or a proof of stake environment. Lawrence Lessig, a Harvard professor, conceptualized smart contracts in the following way. Smart contracts enable promise of performance giving in exchange for promise or performance equals digital contracts. So if you pay $1, you get a cola. Smart contracts can be executed without the state being present. Smart contracts and blockchain technical infrastructure operates without judges and lawyers, enabling people from third developing countries to use basic contract law. So smart contracts were used in the beginning more or less for token deployments, but with the beginning of DeFi, smart contracts are used in many ways. Deployed on many blockchain networks, they enable true decentralized finance in the form of DEXs, decentralized exchanges, lending or borrowing protocols. A DAO, decentralized autonomous organization, is at its core a smart contract. I'm a part of the team where we use smart contracts to enable on-chain communication in the form of decentralized email messaging or data file transfers. So smart contracts can be used in many ways. Once deployed, smart contracts are visible on-chain for anyone to inspect, and they are mostly open source.